Good evening, everyone. I'm Meghna. I'm super excited to share you the really interesting project that is predicting lung cancer using machine learning. Now, I'll walk through the full code step by step and explain it in detail so that you can really build your own project. In this project, we'll cover everything like pre-processing of the data, handling outliners, applying feature selection techniques like PCA, and training and testing of data for KNN and evaluating different machine learning models. Else, by the end of this video, you will have a solid understanding of how real world medical prediction systems work. And definitely, you will be ready to build and improve your projects. Now, let's go through the code and learn the code in detail so that we can build our own code. First, we import all the libraries required for our project, pandas like pandas, numpy, and MATLAB. It is used for plotting of the graphs. And in the next step, this is a data set that is required, and we use this data set for our lung cancer prediction. And we go through different steps like shaping of data, which is used uh, to show number of rows and columns of that data set. And in the next step, data information, all the columns, non-null count and data type will be printed. Data head, which is used to print the first 5 rows of the data set. And the data describe, which gives the statistical information for all the numerical values like mean, standard deviation, maximum minimum values, and its percentiles like 25, 50, and 75 percentiles. And going through the next code, data is null, or it checks whether the given row is either a null or not. In this code, we import the scikit-learn processing from label encoder. Here, what really happens is label encoding. Machine learning models cannot handle text. They can only handle numerical values. So we encode into numerical, which is a non-numerical values, just like our gender. In this gender is male and female. This we convert into a numerical value like zeros and ones. And also the lung cancer prediction, lung cancer value. It is either yes or no. Then we convert that to 1 and 0. That means 1 if the lung cancer is yes and 0 if the lung cancer is no. And let's go to the next part. In this, we visualize the distribution of the code. Here, it shows the number of columns having the lung cancer and not having the not lung cancer. In this, we can clearly observe that the data is imbalanced. There are less number of outcomes with less number with outcome 0 and more number with outcome 1. So for this, and here is another visualization of data. For this, we use SMOT. As you know, SMOT is used to balance the data. SMOT stands for Synthetic Minority Oversampling Technique to balance the dataset by oversampling the minority class. This is an important technique for handling imbalanced datasets. And in our next part, we visualize the data. There is a clear difference between in before using SMOT and after using SMOT. We can find that the data is balanced here. And in the next part, we used IQR for handling the outliners. We know outliners removal is really important to reduce bias. So I have an extreme outliner that can negatively impact the model performance. So we use IQR, which stands for interquartile line. we use Q1 and Q3 and set the lower bound, which is Q1 minus 1.5 into IQR, and upper bound is Q3 plus 1.5 into IQR. Below this lower bound and above the lower bound values will be removed. Here comes. And in the next part, after detecting the outliers, we can handle them by capping. The extreme values capping involves replacing the values that are too high and too low. So the outliers will be replaced by maximum or minimum value. That's how we handle the outliers. And here comes the next part. Uh, we are applying in this part of the code, we standardize to scale the numerical features. The step is crucial, especially for algorithms like KNN and also the logistic regression. And in the next part, data.core. In this step, we calculate the correlation matrix of the dataset using the core function. The correlation matrix shows how different numerical features in the dataset are related to each other. The correlation, definitely we know that the correlation shape is between plus 1 or minus 1, indicates a strong positive or negative relationship. Here comes the correlation shape, explaining the relationship between two different features so that we can remove highly related features. To better understand the relationship between the features and target variable, let's visualize the correlationship map matrix using a heat map. This is the just representation of this above correlation matrix as an heat map so that we can easily understand and visualize. It is actually a graph theoretical representation. In the next part, we split the data set into training data set and also the testing data set. This is crucial step because it allows us to train the model on one portion of the data and test it on another portion of data. This is how we do it. Train test split. Train test split is used to split the data, and in this percent, test size of the code is 30% and the train data is 70%. As we all know that the train data must be more than the test data for the clear understanding. In this, we are training the k nearest neighbor models, that is KNN model, and evaluating its performance. Here you can see the performance like accuracy, precision, recall, F1 score are the performance matrices we used. This is an important step in model evolution so that we can definitely understand between them. Let's understand what accuracy, precision, recall, F1 score really is. Accuracy measures the percentage of correct prediction, where precision is the proportion of positive predictions that are actually correct. Recall the portion of actual positives that we correct identified by the model, whereas F1 score is a harmonic mean of the precision and also the recall. In this, we apply the decision tree classifier, which is very imprintable model that makes decisions by splitting data at each node on its feature values. It's especially used for classification techniques. In this, we evaluated the matrices, which has an accuracy of 92 percentage, which is greater than KNN. In the next model, we have going through is the logistic regression. Let's discuss about logistic regression, which is widely used algorithm for binary classification problems like predicting whether a patient has lung cancer or not. Here, the outcome is a binary, either a 0 or 1, so that we can use a logistic regression. Whereas for other cases, if the outcome is not a binary, then definitely we cannot use the logistic regression. Now let's train the random forest model, which is an ensemble learning method that combines multiple decision trees to improve the overall prediction accuracy and reducing overfitting, which gives an accuracy of 95%. As we discussed, this is a combination of many decision trees. So definitely it goes through many training and testing. So it has an highest accuracy when compared to the decision tree. And the next part is XGBoost, which stands for Extreme Gradient Boosting. It is an advanced version of gradient boosting and one of the top models for classification and regression tasks. XGBoost works by building decision trees one at a time, where each tree tries to correct the error of the previous tree, which makes it highly complex data set. Here we can see even the XGBoost gave an accuracy of 95%. And here comes the final model of our project. It is Navy Bayes. Navy Bayes classifier is used in Gaussian Navy Bayes variant. Navy Bayes classifier are based on Bayes theorem and assumes that features are conditionally independent, which is often a good assumption when dealing with a large data sets. Yes, we can see the Navy Bayes classifier, which is a 95% too. In the final part, here we you are assuming the performance of all the models you have trained by displaying their accuracy. As you can see in the outcomes, we have plotted a graphs for accuracy, precision, recall, and F1 score in a data frame. Then we are visualizing this matrix in the graph plots, as you can see, and compare which different classifiers to know which classifier is the best so that we can continue with this. Finally, let's compare the performance of all the models we trained. We have trained, evaluated each model in many parts like accuracy, precision, and F1 score. Now we summarize this metrics for each model in a data frame, making it easier to see in which model performed the best. Now you can see here the graph and the visual representation. And these are the bar graphs. In this we use these graphs we plot by using Matplotlib. And next, let's go to the next part, which is a hybrid feature selection. In this, we are going to perform hybrid feature selection using principal component analysis. As we know, it's PCA. PCA is powerful technique for reducing the dimensionality of a data set while maintaining as much as information as possible. Now, in this, we can see the original number of features and the low variance features, and which are also the highly correlated features. First, for PCA, first we define hybrid feature selection technique that takes a feature matrix and reduce its dimensions based on the number of principal components we want. Uh, so that we can remove the features. Here comes the part in which we apply we perform PCA using different components like 5 components, 7 components, 9 components to take the best number of components. Sometimes it may leads to underfitting and overfitting. To avoid this, we use 3 of them. In our case, we can see the performance matrices before, after feature selection with 5 components, 7 components, and 9 components. On comparing the accuracies, definitely you can see components with 7 gave the high accuracy. Uh, yeah, in this, you can clearly see the plotting of the PCA. Let's plot. Here comes the plotting of the PCA. before you can see this violet represents 5 components and 7 components, and green represents 9 components. Definitely in this graph we can clearly see that with 7 components the accuracy is high, so we'll go with 7 components. And in the next part of the code we'll go with a graphical representation in which we compare the performance of multiple models before and after PCA by looking at various matrices like accuracy, precision, and recall. Each model performance is evaluated with 5, 7, and 9 principal components, and we have used different patterns to help and so that you can really distinguish between each bar. From this, we can definitely acknowledge that in most of the classifiers, components of 7 has the highest accuracy. Moving on to the next part of the code, in which you can see the output, in which we can give the PCA analysis of variance ratio. You can clearly see the output. Let's go to the next part of the code, which is our main function, in which this code you have performance a principal analysis on dataset, extracts the model features for each principal components, and then create and you can see the table of PCA of different components 5, 7, and 9. Here is the ending of the code. And the key steps from these are standardization, PCA componentation, creating summary table. And thank you everyone for watching this.